When you hear about green hydrogen projects, you probably think of massive solar farms, giant wind turbines, and government funding. But there's a critical ingredient that's almost always overlooked: water. Without water, there's no hydrogen. More importantly, without ultrapure water, the whole system grinds to a halt. Today, we're diving into the hidden water story behind three of the world's biggest hydrogen projects: Plug Power in California, Iberdrola in Spain, and the mega project NEOM in Saudi Arabia. We'll uncover why water treatment is one of the biggest hidden costs and risks in the race for green hydrogen. So why does the water have to be so pure? Well, the process of electrolysis, which splits water into hydrogen and oxygen, is incredibly sensitive. Impurities like salts, minerals, or even tiny organic particles can wreak havoc inside an electrolyzer. They can clog up membranes, corrode expensive parts, and drastically shorten the life of the entire system. Think of it like putting dirty fuel in a high-performance engine. It is a recipe for disaster. This means every single hydrogen project needs a sophisticated water treatment system, custom-built for its water source. Whether it's city water, recycled wastewater, or even seawater, it has to go through multiple stages of purification, like reverse osmosis and deionization, just to get clean enough. Yet companies often talk about megawatts and production targets, leaving the water part as a footnote. But without that water, the numbers are just fantasy. Let's start in California with Plug Power's Mendota project. This plant plans to make 30 tons of green hydrogen a day using solar power. But California is a drought-prone state, so where does the water come from? Instead of using precious fresh water, Plug Power is doing something brilliant. They're partnering with the local city to take treated sewage water and purify it even further. The project will process about 1.2 million gallons of recycled water daily, with the hydrogen plant itself using only about 10% of that. This is a huge win-win. The hydrogen plant gets the water it needs without competing with farmers or residents, and the city gets a brand new, sustainable water recycling facility. It's a great example of how hydrogen can actually help solve local water challenges. However, the full story isn't public. We don't know the exact purification technology, its cost, or how reliable it will be. For engineers and investors, these missing details represent risk. What we do know is that this approach, turning hydrogen into a driver for water reuse, is incredibly promising. Now, let's fly over to Spain and look at Iberdrola's Puertollano plant. This is one of Europe's most advanced hydrogen facilities, powering a local fertilizer factory with green hydrogen. The project combines solar power, batteries, and a 20-megawatt electrolyzer. It's a showcase of clean energy integration. But again, the water story is tucked away. We know they have a dedicated water treatment facility. They have to for their advanced electrolyzers. But the real puzzle here is flexibility. Solar power isn't constant. It fluctuates with the sun. As the electrolyzer ramps up and down with the available power, so does its demand for water. This means their water treatment system has to be just as flexible. Did they build a huge system that can handle peak demand, which is expensive? Or did they build a modular system that can turn on and off, which is more complex to operate? These are critical design choices that have a massive impact on the project's bottom line, but you'll rarely see them in a press release. Finally, we arrive at the most ambitious project of them all, NEOM in Saudi Arabia. This is a true giant, aiming to be the world's largest green hydrogen and ammonia plant. We're talking an $8.4 billion investment to produce 600 tons of hydrogen per day. Located on the coast of the Red Sea, NEOM has only one option for water: the ocean. This requires desalination on an epic scale. To produce that much hydrogen, they'll need over 5 million liters of ultrapure water every single day. And that's before accounting for water lost during the purification process. The actual intake from the sea will be much larger. The engineering challenge is immense, but NEOM is aiming for something revolutionary: 100% renewable desalination with zero harmful brine discharge back into the ocean. Normally, desalination plants pump super salty wastewater back into the sea, which can harm marine ecosystems. NEOM claims they will recover valuable minerals from the brine instead. If they pull this off, it will be a world first, setting a new standard for sustainable industrial water use. So, what have we learned from these three projects? Plug Power shows how hydrogen can boost municipal water recycling. Iberdrola highlights the need to sync water systems with the ups and downs of renewable energy. And NEOM demonstrates the incredible challenge and opportunity of turning seawater into hydrogen fuel without harming the environment. In every case, the specifics of water treatment are the unsung hero, the critical component that determines if a project is truly sustainable, bankable, and successful. Water treatment isn't a minor detail. It's a central pillar of the entire green hydrogen economy. An undersized system means costly downtime. The wrong technology means high operating costs and hazardous waste. So the next time you see a headline about a new multi-billion-dollar hydrogen plant, ask the important question: where is the water coming from? How are they cleaning it? And is it truly sustainable? The answers to these questions will ultimately decide the future of green hydrogen. If you want to understand these technical and financial details better, we explore them in our Green Hydrogen Project Development and Financing course. We even have a tool that lets you design your own water treatment systems and see how your choices impact the final cost of hydrogen. The lesson from NEOM, Iberdrola, and Plug Power is clear. Without solving the water challenge, there is no green hydrogen future. Thanks for watching. If you found this interesting, please give us a like, subscribe to the channel, and hit that notification bell so you don't miss our next deep dive into the world of clean energy.